In this video, we'll write the balanced net ionic equation for SrCl2 plus MgSO4. We have strontium chloride and magnesium sulfate. So the first thing we need to do with net ionic equations, we need to balance the molecular equation. In this case, the molecular equation, it's already balanced, so that's kind of nice. Next, what we'll do is we'll write the state for each substance. That'll look like this. So compounds with the chloride ion, they're very soluble. So these two substances will be soluble, and compounds with the sulfate in general are soluble, with a few exceptions. And one of the exceptions is strontium sulfate. Strontium sulfate is insoluble in water. So when these two substances react, we form the strontium sulfate. It's insoluble, so it falls to the bottom of the test tube as a precipitate. So those are the states. Now what we need to do, we need to split the strong electrolytes into their ions for the complete ionic equation, and that looks like this. Note that we don't split solids apart in net ionic equations, so we've kept the strontium sulfate here together. Now we can cross out the spectator ions. They're on both sides of that complete ionic equation. So in the reactants, I see two chloride ions right here, and again in the products, so we can cross those out. They haven't changed. They're spectator ions. I also see I have a magnesium ion right here, and again, in the products, spectator ion, we cross that out. What's left, that's the net ionic equation for strontium chloride plus magnesium sulfate. I'll clean this up, write the states, we'll have our net ionic equation. So this is the balanced net ionic equation for strontium chloride plus magnesium sulfate. Note charge is conserved. We have a 2 plus and a 2 minus. So the reactants, we have a net charge of 0. And strontium sulfate, that's a neutral compound, net charge of 0. Charge is conserved, and if you count the atoms, they're balanced as well. This is Dr. B with the balanced net ionic equation for SrCl2 plus MgSO4. Thanks for watching.